Hi everyone, welcome back to Lulumath. This video is on multiplying binomials by binomials, and we're going to use the method of FOIL, which is a very common method. There's another method that I have a video on that is more for visual learners. So if you're a visual learner, make sure you check that video out. But before we do that, you need to have some background knowledge. You need to know a couple of things before you can actually FOIL. So the first thing you need to know is how to multiply monomials by monomials. If you need a refresher on how to do that, make sure you check out that video that you can find on the YouTube channel or at lulumath.com. And the second thing you need to know is how to multiply monomials by polynomials, or pretty much you're distributing monomials to those polynomials. Remember, monomial means one term, polynomial means several terms. Again, if you need a refresher on this, make sure you check that video out. So in this example that we have here, we're asked to expand x minus 5 multiplied by x plus 7. So if you notice, this is a binomial multiplied by a binomial because we have two terms in our first expression and we have two terms in our second expression. So essentially what we did before, where we would distribute a monomial to a polynomial, we want to split this up so that way it's easier to distribute. So I need to make sure I take this x and I distribute it through to this entire binomial, this x plus 7. But if I'm going to do that with this x that we have here, I also have to do it with this negative 5. So this negative 5 also has to get distributed through to this x plus 7 as well. So if I were to write this out, I would take my first x that I was talking about and I would distribute it through to this x plus 7 binomial here. But again, if I'm going to do it with the x right here, I also have to do it with this minus 5 and distribute that through to x plus 7 as well. So I would distribute x to x and I would end up getting x to the power of 2, because remember, x to the power of 1 times x to the power of 1, add your exponents, you get x to the power of 2, plus x times 7, which is 7x, okay? Then we're going to take this negative 5 right here and multiply it by x, and I would get negative 5x. And then I would distribute negative 5 to the 7, and I would end up getting minus 35. Well, 7x and negative 5x are like each other. So if I were to put those two together, I would get 2x, because 7 minus 5 is 2. Nothing is like this x squared, so I'm just going to copy that down. And nothing's like this negative 35, so I'll just copy that down as well. And this is my simplified expression for this x minus 5 multiplied by x plus 7. Now, mathematicians are always looking for quicker ways to do this. So instead of having to write this whole thing out, we're going to use a method called FOIL. Now, if you're going to use FOIL, you have to understand where it's coming from. Don't just memorize the steps, but understand what it is that we're doing. So it comes from what we did here, and I'll explain to you how that is. So if you remember, we ended up taking this x right here, which was our first x here, and we multiplied it by the x in the second expression. So it was this x multiplied by this x in the second expression. If you see here, this is the first term in my first binomial, and this is the first term in my second binomial. So the first thing we're going to do is multiply our first terms. So we're going to multiply x by x, and we end up getting x to the power of 2, or x squared. Okay, then we took this x right here and we multiplied it to the 7. So it was this first x that we see here, we multiply it to the 7 here. Now if you notice, this x is the outermost term on the left side, and this 7 is the outermost term on the right side. So I'm multiplying my outer terms. So I would multiply x by 7, and x times 7 is simply 7x. Okay? Then we took this negative 5 that you see here and we multiplied that through to the x right here. So this negative 5 that you see here, we multiplied it through to this x right here. So next thing we did was we looked at our innermost terms. So negative 5 is the innermost term on the left side, and x is the innermost term on the right side. So next thing we did was inner. So negative 5 times x is negative 5x. Okay, and then finally we took this -5 here and we multiplied it to this 7 over here, which is this -5 multiplied by this 7. Now, if you see, this is the last term in my first binomial, and the 7 is the last term in my second binomial. So I'm multiplying my last terms together. So -5 times 7, which is -35. Okay, that's where FOIL came from right here. So this is how we get the letters FOIL. That's what they stand for. Now, a couple things. Multiplication is commutative. And what that means is that the order doesn't matter. So we write it out as FOIL because that spells out a word that we're familiar with. But if you wanted to, you could do fully if you wanted to. You could first outside, first outer, last inner. You could do Lyof. Doesn't really matter. You can do any combination of these four letters as long as you distribute every single term in the first binomial through to every single term in the second binomial. Okay. Now, lastly, we have to put everything together. So we ended up getting x squared. Then our next term was 7x. So we're going to say plus 7x. Our next term after that was -5x. So we'll write minus 5x. And then, so that's what we got here. And then our last term that we have is -35. Again, because 7x and -5x are like each other, you get 2x. Copy down this x squared. Copy down this -35. And this is your final answer. Okay, let's take a look at this next example that we see here. Now I'm going to write out the letters for FOIL. So we've got F stands for first, O stands for outer, I stands for inner, and L stands for last. So for my first terms, I'm going to look at the first term in my first set of brackets right here, and I'm going to look at my first term in my second set of brackets that we have here. So I'm going to distribute 2x squared through 2x right here. And 2x squared times 1x to the power of 1 is 2x to the power of 2 plus 1 is 3. Okay? Now this time I'm not going to write it out on the side here because again we look for quick, easy and efficient ways to complete the simplification. It's not necessary to write it out every time. I just wrote it out last time for clarification. Okay, now we're done with our first term. Let's look at our outside terms. Well, our outside term on the left side is this 2x squared, and our outside term on the right side is this 8. So it's 2x squared times 8. Well, 2 times 8 is 16, and then x squared is being multiplied by, technically no x is here, so multiplied just by 1, so I get 16x squared. Okay, now I'm going to look at my inner terms. So this -9 right here is the innermost term on my left set of parentheses or brackets. This x is my innermost term on my right side of parentheses or brackets. So I'm going to multiply -9 through to this x right here, which gives me -9x. Okay, I'm done with my inner. Now I just have to look at my last. Well, -9 times 8. -9 is the last term in my first binomial. 8 is my last term in my second binomial. So I'm going to write minus 72 because -9 times 8 is 72. -72. So looking at this right here, 2x cubed, nothing is like it because there are no other x cubed terms. 16x squared, nothing is like that. There are no other x squared terms. -9x, there are no other x terms, so nothing is like -9x. And then -72, there are no other constants or terms without variables, so nothing else is like that, which means that this right here is my final simplified answer. All right, in our last example, we're asked to expand the quantity 3x minus 1, all of it squared. So I just want to talk about a common mistake that people tend to make first before we go ahead and talk about how to actually find the correct answer. So a lot of people will say, oh, well, I see the squared on the outside, I'm just going to square each term on the inside. So 3 squared is 9, x squared is x squared, and then negative 1 squared is positive 1. And this right here is incorrect. So what I want to do is graph out a parabola that would say y equals 3x, the quantity 3x minus 1 squared. And I want to graph out y equals 9x squared plus 1. And if these two expressions were equivalent to each other, this one and this one, then our graphs would look identical. So let's go ahead and do that. Y equals, I'm going to put in brackets 3x minus 1, close my brackets, and then I'm going to square it. And then for the other answer that we got was 9x squared plus 1. And if you notice, we have our red parabola, which is our top one up here, and we have our blue parabola, which is our bottom one down here. They don't line up, which means that our expressions here are not equivalent. It's a very common mistake people will make. Don't fall into that trap. Okay. So if I have 3x minus 1 quantity squared, it means that I'm going to take 3x minus 1, and because it's squared, it means to multiply uh, everything by itself. So I'm going to multiply 3x minus 1 by 3x minus 1, okay? And then I'm going to write out my letters for FOIL. You don't have to write it out every single time. I'm just doing this for the sake of understanding what's going on right now. So F stands for first. So the first term in my first binomial is 3x, and the first term in my second binomial is also 3x. So 3x times 3x, 3 times 3 is 9, and x to the power of 1 times x to the power of 1 is x to the power of 2. So I finished the first. So now I'll do outer right here. So the outer term here is 3x, and the outer term here is negative 1. So negative 1 times 3x is negative 3x, okay? Then I is inner, so my two innermost terms are negative 1 times 3x, so I get another negative 3x, okay? And then I'm going to do my last terms. L stands for last, so negative 1 and negative 1 are both my last terms. Negative 1 times negative 1 is positive 1, okay? Now we have 9x squared, nothing is like it, so I will copy it down, okay? And then we have this negative 3x is like this negative 3x. They don't cancel out because you have a negative and then you're going even more negative. So we actually end up with negative 6x. And then we have this plus 1 right here. And that is going to be my final answer right here. I'd like to make a really important note. You can only use FOIL if you're going to multiply a binomial by a binomial. FOIL will not work for any other type of expansion. But the good news is you can expand it like we did in our first example with the x minus 5 times x plus 7. Or if you watch the video with the geometric model, you can use that model for any type of expansion that you'd like. Thanks for watching. If you have questions, please comment below or reach out at lulumath.com, where you can also find blank or completed notes from this video. If this was useful to you, don't forget to subscribe for more videos and share with others. Thank you. See you next time.